today, actually, we're going to discuss technology that's based on carbon dioxide and water. So we're discussing what we believe to be, rather than evolutionary technology, revolutionary technology, which is something completely new. And really, we're talking about something which we believe is going to be game-changing. So, okay. So indeed, you know, we heard a lot about biofuels, a lot about fuels from natural gas, from fossil resources. Why not fuel zero cost? This was mentioned this morning, actually, which means that we could use carbon dioxide, we could use water, and we could use energy from the sun. Combining these together, we can get real fuel. And so one aspect that was not mentioned in the common scheme is the energy density of the fuels, and you can see here a chart that clearly shows that the fuels that are normally used today, from gasoline to jet fuel and to diesel fuel, are all of a much higher density than ethanol, methanol, or the other alternatives. But this is not the main issue. The main issue is that you see, and you see here on this chart here, actually broad definition of all the various processes that are practiced today. And there are many issues related to the environment, carbon emission, issues related to land and food, and other issues. And by just using carbon dioxide and water, one can avoid all those issues. And what we're relying on is to take water, split it into hydrogen and oxygen, and use the hydrogen with the carbon dioxide in a catalytic process to produce fuels. So just a month ago, this analysis came out, which compared on the right-hand side, the process actually that we're proposing compared with the other processes in the middle there. You see the algae and the algae-based biomass, and you can clearly see from this analysis that indeed, just by doing this directly, one can get a much higher efficiency of sun to fuels. So this certainly looks very good, and so we've been involved in research and development of renewable fuels for the past decade or so. We've done many processes, but we focused on this particular one for the past 4 years. And we as an academic institution practice both fundamental and applied research in what we would call use-inspired research and trying to come up with the results. And indeed, we have a fairly large team of researchers, of technicians and students that work together on such processes, and actually,
Researchers at the Fleshner Center for Industrial Catalysis and Process Development have developed technologies for production of liquid fuels, including a high-profile project with ExxonMobil. A patented technology for the production of advanced green jet fuel from vegetable oils is ready for commercialization. While the ambitious task of producing liquid fuels from carbon dioxide and hydrogen produced from water is now being pursued.
So we have already had several commercial applications. One of them, you can go and see it, actually in what you can see it in the Ramat Hovav area, which is in the southern part. The company called Negev Aroma, and this is the kind of product that we developed, and it's now being practiced commercially. So, again, the idea is rather simple. We want to split water into hydrogen and oxygen, which we'll be using hydrogen, but as a matter of fact, if we go into the more details of it, we actually will be using oxygen as well. But the hydrogen is the main component. Then we have a catalytic process, which although was a real challenge to develop it, both the catalyst and the process configuration. The current process, the way it looks, has a catalyst that's based on iron, which is the most abundant material on Earth, and it's very cheap, obviously, and it uses the technology that's being used today in a refinery. We just do it differently with a different catalyst. So this would convert carbon dioxide and hydrogen directly in what we call green feed, and then by using very well-established technology, we'll just convert the green feed directly into high-performance fuels. And we do not need, in this case, to discuss infrastructure, because there is no infrastructure here. We'll just take those fuels and market them the same way you would market the fuels that are being used today, the gasoline, the jet fuel, and the diesel fuel. So here is the deal. We have crude oil. The crude oil goes into a refinery, and it produces the three major products, the three major fuels. What we propose to do, as I pointed out, is to take, we hope so, take solar power, wind power, but for the time being, for certain opportunities, although it's not that renewable, we could use also electricity from power plants. Today, one can use electrolysis to split water, and it's being used today at a fairly large scale, at a commercial scale, producing about 1 ton of hydrogen a day. It's being used in various parts of the world, mainly in Germany. But in about 5 years, we expect this to be scaled up to much larger scale. So this is viable. Then we capture CO2, and this is a very well-established technology. And actually, with the carbon tax, the cost of the carbon dioxide may be even below zero. And so this is our process here, which we call it the green feed production. Put it into the refinery and get the fuels. Obviously, it's more complicated than the way I show it to you here, but that's the essence of it. And so, as you see here, we're ready to take off, which means that we have the technology. The technology is proven. We filed patents on it. We pretty much completed the work on bench scale. Scale-up of such a process is simple and well-established, so any engineering firm would be able to build it that's experienced in the field. And so we believe that we can move up very quickly. And indeed, we have already identified some business opportunities, and we're ready to move forward. And finally, I'd like to thank several foundations that were involved in funding our work here. And thank you again for inviting me here.
No, that's good. I know, it's, again, very un-Israeli of you to finish early, but I've got a question for you, actually. And
yes.
It's been a while since I did my chemistry A-level,
Good.
but as you said there, you need energy to split
Right.
to get the hydrogen out.
Right.
So I'm just wondering, even if that energy comes from the sun, you can't be creating more energy than you're putting in, or even the same, because then you've got your perpetual motion and everything else, right? So I'm just wondering, wouldn't it be more efficient to take the energy from the sun into a power station or whatever, and get your power for your car from the grid in an electric car, rather than creating a liquid fuel that ultimately has less energy than that which you had to put in the first place?
This now would be a very long discussion about various alternatives, okay? Which means that on one hand, you have the batteries and the grid and the electricity and everything else. On the other hand, you have the fuels. The fact of the matter is that there is a market out there that you have to do it. And when you do the calculations, it gets to be more elaborate than just a simple energy calculation. We definitely rely on energy to split the water. And I must tell you that today, there are billions of dollars spent on water splitting. Only in the US, there are several major programs, hundreds of millions of dollars on water splitting. So, you know, this technology is moving forward. It's producing hydrogen, and I guess in the US have already made a decision not to go to a hydrogen market. So we're here to remove to remove CO2, and to make real fuels.
Okay, and just very finally, in our final 25 seconds, when do you expect or hope for this to be commercialized? I know you said you're...
Well, in the larger scale, we say 5 to 10 years, but we are already seeing some commercial opportunities, and we hope to be able to see demonstration plants over the next 2 years or so.
Okay, well, we wish you Batzlacha, Professor Moti Hershkowitz, ladies and gentlemen.